Let's look at the acid-base theories. In other words, how do different people define an acid and a base? And the first theory of an acid and the base that we want to look at is the Bronsted theory. So according to the Bronsted-Lowry theory of an acid and a base, so these were two scientists who came to define that. Firstly, starting with an acid, they said that an acid is a proton donor. So that means any compound that is going to donate a proton. And in this case, when we're talking about a proton, we refer to an hydrogen ion. So anything that donates an hydrogen ion is a proton donor. An example that we can give, which you can say is a Bronsted acid, is, let's consider this, when HF reacts with water. What is going to happen is this hydrogen is going to be donated to the water there. So the F will just remain as F minus and the water becomes H3O plus because it has got an extra proton or it has got an extra hydrogen ion. And so this compound here is a Bronsted acid. Okay, now let's consider what a Bronsted base is. A Bronsted base is defined as a base is a proton acceptor. And same, when we talk about proton, we are referring to an hydrogen ion. So we are defining an acid and a base in terms of just hydrogen ion according to Bronsted theory. It's just hydrogen ions. For example, an example that we can give is, let's say we are talking about a carbonate and it reacts with water. What is going to happen is that water is going to donate an a proton. One water molecule donates a proton and that becomes now HCO3 and a minus, and then you are going to have an hydroxide. Now in this case, this compound which donates a proton is an acid. So in this case, water is a Bronsted acid. This one which accepts that proton is a base. So in this case, this is a base. And that is how we define a base according to Bronsted theory. Now the second theory that we want to get to understand is the Arrhenius theory. Now according to Arrhenius, what is a base and what is an acid? Well, according to this theory, an acid is any compound that increases hydrogen concentration. An acid is any compound that increases the concentration of hydrogen ions in solution. So this is what we define as an Arrhenius acid. For example, any acid that is going to make a lot of hydrogens in solution, that is going to be defined as an Arrhenius acid. For example, if you've got hydrochloric acid, this reacts with water. So in a solution, hydrochloric acid is going to give out the hydrogen. So we are going to have, okay, this is not water that I've put, H2O. So we're going to have just H3O. So the water gains an extra hydrogen to become oxygen ion, and then the chlorine remains alone like that. So this has donated an electron to that one. It has increased the number of hydrogens in solution. So basically they are more like the same, Arrhenius acid and Bronsted-Lowry acid. The only difference is that when you're talking about Arrhenius, we're talking about in terms of increasing. Now a base, in terms of Arrhenius theory, a base is any compound that increases the concentration of hydroxide. So that increases the hydroxide concentration in solution. Alright, so that is what we call a base. An example that we can give for a igneous base is, let's talk of sodium hydroxide. Sodium hydroxide there. Well, sodium hydroxide dissociates in water, forming sodium ion and hydroxide ions. And these hydroxide ions will increase because the presence of water will make the hydroxide all the more. Water has got hydroxides and hydrogen ions, plus these hydroxide ions which are coming from the sodium, and so it is defined as an igneous base. Alright, but a Bronsted base is just a proton acceptor, so that is a difference. Now the last theory that we need to get to understand about acid base theories is the Lewis theory. Well, according to Lewis, what is an acid and what is a base? Well, Bronsted says an acid is a proton donor, but Lewis says an acid is an electron pair acceptor. An acid is an electron pair acceptor. Electron pair acceptor. And base is the other way around. A base is an electron pair donor. Now, what example can we give when we're talking about the Lewis acid and the Lewis base? An example that we can give is when ammonia, which is NH3, let's say ammonia NH3 is going to react. Okay, sorry for that. Okay. Ammonia, what we are going to have is another hydrogen here, another hydrogen here. Now ammonia has got two lone pairs, like that. If this reacts with, let's say, BF3, this compound, which doesn't have any lone pair, so what happens? So what is going to happen is ammonia is going to donate its two protons. This one doesn't bring anything. It's only ammonia which brings these two protons, and both of them share the two electrons in this case, not the protons. So we're going to have your ammonia like that. And you are going to have now the other compound this side. So the two electrons are going to form a single bond. So those are going to be shared on the middle like that. Or we can just put that as a bond because two electrons form a bond. Now in this case, we can see that the ammonia is the one which was donating two electrons. That is an electron pair. And so the ammonia is a Lewis base. So this is the Lewis base. And the other compound was just accepting. Okay, so this is the Lewis base. The other compound is just accepting electrons. So this is a Lewis acid. So these are the definitions of acids and base according to different theories which have been put out. Thank you so much for watching. Stay blessed.